Wonderful. For our talk tonight, we had to reach out all the way to Vienna to get our speaker here. We got Paul. He calls himself a software gardener. And what places do railways have in our favorite programming language? Fuck. All those questions, he has all the answers. Please give a big round of applause to the speaker from tonight, Paul Rohorzka.
Thank you. Thank you. Battery should be fine by now. May I have the clicker? So, perfect. Okay, welcome to my talk. We're talking about some ideas of functional programming within our beloved language C# that we use probably from day to day. And the main focus at the end will be railway-oriented programming as one of the aspects that you could do to get more functional with C#. Do I dance too much around? Okay. As Christian already said, thank you for inviting me. My name is Paul Rohorzka. I'm working at Square Solutions. Consider this a queue here. In Vienna, we are in Vienna and Munich. We are around 90-ish people currently. And we are also doing the CodeCrafts conference now. We did it last week for the 4th time. And it was a really nice conference in Vienna. Some of you have been there. Yes, officially I'm called the principal software engineer, but I way more like this idea that also you mentioned already, the software gardener, because being around and nurturing the things and cutting off the dying things is something that I really like also in software. Yes, and this talk was originally done with a colleague of mine. I just mentioned him here. He's on educational leave. That's the reason why I'm standing here alone. So what to expect? We will be talking about some ideas of programming paradigms, about what does it mean to be functional or object-oriented. We will have a big focus on railway-oriented programming, and I will also try to share some of the experiences from the field, from using it in real production software. Okay, if we take a look at programming paradigms, there are a lot. But the two that I want to focus on today is the one paradigm that is declarative. So, and this is functional, for example. This might be reactive programming, for example, or imperative. And this is, of course, procedural or object-oriented programming. And if we take a look at what does it mean, here are two very simple examples. One on the left, this is typically imperative code. So you say, I want you to do this, iterate over these numbers, and if that happens, then make some calculation, and as long as there are numbers, do it. And the other thing is that I talk more about what I want to have. That's the way that we can do it in links, same result as to the left, but in a different way to express. I just say, okay, I have the numbers, I just take those that are even, and I want to have the sum at the end. It's the same, but a little bit different expressed. So if we are talking about functional programming, so we should probably talk about functions. So let's cook. Let's start with a cook. So this is a cook, a chef, and this chef takes ingredients, knows how to cook, and produces some nice food. And this chef has also a mood. That could be up, that could be down from day to day. We don't know. And if the chef is happy, he has a perfect mood, he takes the ingredients and makes a great salad, for example, out of it. If his mood is not so well, then he might just forget about all the vegetables, just take the rice and make a rice bowl, cook in it. Nothing like that. So what we have here, we have a thing where we don't know what it does until we try it, because it's depending on the mood. And that's what we usually call a state. So we have here a state, and the state has to be considered as just another input to the thing that the cook is doing in that case, that the chef is doing, cooking, and influences what's coming out of it. On the other hand, if we take now another chef, here's Bertha, and Bertha has no state. So she has no mood swings. She's just a stable person. So every time we give her these ingredients, we say, cook, she produces that perfect, nice salad. So if we take a look what that means, of course, that's an example or a synonym for code. And so if we take a look at this very simple function, we see, okay, this is a so-called pure function, because what does it make pure? Several things. One thing is that the output that it produces just depends on the things we put inside. The output does not remember anything from the past, for example. So it does not have any state. Moreover, the output also has no side effects. What does that mean? That means no matter how we call it, it will leave no traces. Besides maybe increased memory consumption and the CPU has to do something. But on a language level, we have no traces. So no state is changed somewhere, for example. Or we do not call out to some web service, because that would be a side effect. And this is deterministic. So every time we call it with the same input parameters, we get exactly the same output. What is the typical example for a not deterministic function that is still stateless and has no side effects? A random number, yes, right. And another one? If you're asking for the time, if you're asking for the system clock. Because every time you ask, you get a different answer. And that's not deterministic. So these are the things that you might look for. And if you're talking about a pure function, we combine all these three characteristics. Okay, when we take a look about what makes a language object-oriented and what are some parts of functional programming, then we see a lot of things that are kind of the opposite of each other. So in object-oriented, we have imperative, and functional, we are declarative. In object-oriented, we usually combine the methods, so the things that can be done, the functions, the behavior, together with the state. That's what we call an object or class if we instantiate it. And on the other side, in functional programming, we go for functions. Functions that living on their own, doing nothing else but calculating the input values and giving the same output value every time. We are talking about usually a lot of mutatable data, so data that can be changed. On the other hand, if we are going functional, we will definitely try not to ever mutate data as far as we can. And so there's other things going on as well. And if we take a look, where does C# support us? Of course, it will support us, hopefully, on all the things on the object-oriented side, but also on the functional side, we're not so bad, I would say. There are things, of course, we're still missing. There are things, if you write it in C#, do not look very nice because it's too much craft around it, and in a language like F#, for example, it would be way nicer. But still, most of the things we can have. But we really have to care about as a person, or maybe the tooling has to really support us so that we care about that we do not mutate data, for example, and really go for immutable data. Okay, when we take a look at what Microsoft says about C#, then it's interesting, why would you ever go and think about doing something functional with C#? Because Microsoft clearly states C# is an object-oriented programming language. Yeah, but I think as we know, that's not the whole game. There's more to it. And we could ask ourselves, okay, we are in the Microsoft ecosystem, nice. We are going to use C# and want to do functional, why not go to the F# language? I guess the answer for most of us will be Yeah, because we're living here. We're living in the C# world. We know it very well. So maybe it could be an idea to try to incorporate some of the ideas that a real functional language has in our well-known C# language. And if we saw this definition from Microsoft what C# might be, if we take a look at what Wikipedia says, it's even more nuanced, because here it says C# is a general purpose high-level language supporting multiple paradigms. And here it also mentions functional paradigm. And that's why we are here, because we can do a lot of things. We can use a lot of functional ideas or ideas from the functional programming paradigm and also use it in C#. Not as nice, not as well supported by tooling probably, but still we can if we want. If we take a look at the history of the C# language, so we were talking about 2001 and C#1. It's a long way that we came here until it was C#9 5 years ago and up to now C#13 currently. There's a lot of features that came to the language that somehow support going in the functional direction. Not all of them are typical functional features, but still helping and supporting. So for example, we got record types, we got made it easier syntactically to really have immutable types. We have diverse improvements regarding lambda functions that of course very important if it's going functional. We had introduced the list patterns that makes it very terse to write some list expressions. And so a lot of tiny features that really make it more convenient from version to version. I just have to admit in the last list I didn't see too much that would contribute to functional programming. Please correct me if I forgot something. One thing, if we are going about functional programming, is that we do not just consider data like strings or numbers or structs as data and first-class citizens, but also functions as first-class citizens. That means that I can return a function from a function, for example. I can assign a function to a variable, and then I can pass around that variable, maybe even mutate it somehow, maybe do something with it, and then, because it's a function, call it. And in the simplest case, it could look like this. You could have a method that's called getOperation. You pass in some argument, it's a character in that case. You get out not a result, some number of this addition, but you get out the operation. And then you can take that operation, pass it around, and when you then need the operation to be performed, then you can just call it as any other method. So that's where we can see, okay, a function is really the same thing from that perspective as an integer or a string. We can pass it around and return it from a function, for example. How could it look like? Maybe like this. So if you like fancy one-character stuff, then it could look like this. I really like it because it's so regular and nice. And here, what we're doing here, we are using a switch expression, and we say, okay, depending on the operator that we get in as a parameter, we return just another method expressed as a lambda function. So pretty easy. So what we get back is exactly this or this or this or this, or an exception is thrown. That's one thing that might be better in other languages, where we could have better exhaustiveness checks here when we are more explicit at what we are getting in here. Yeah, but still a thing in the right direction, probably. Yeah, here is the same call that we also saw before. How could we do that otherwise? Other example. So for example, you have a more involved process that might even reach out to other systems and databases and network and whatnot. And you have an old implementation and a new implementation. But for the caller, it should be totally transparent what to use. So he should not have to care about. He's just configured it somewhere in the config of his application and passes that to that get process. And out comes the function that actually does it. And nobody here on that level of the code has to care about all the details that are happening behind the back. And how could that look like? yeah, maybe, maybe something like this. So it could just be another branching. So this is just a ternary operator where we say, okay, if the config says legacy processing, then do all the nasty things that I don't want to see anymore, but some people still have to use the old one. So there's a lot of blah and states and something and some weird things to be initialized with a lot of flags and so. But there's also the new one, the fancy one. And the nice thing is, I have to care about all these nasty things just here and return the function that actually provides the functionality that is needed from the caller side. And in that case, I just say, okay, I give you a function, and as long as you pass me an array of bytes, I will get you back a string. And you don't have to care how I do it. So that's not bad. Of course, in object-oriented programming, we also can do that. We all know that, because there's a lot of mechanisms that we can use for that situation. So for example, we could do it like this, different API, but same idea. You can say, okay, I define an interface called a messenger, where I have a send method, is asynchronous, it gets some data, and then at runtime or at startup time maybe, I decide which of the implementations I have in place actually get used when the client wants to send his string to wherever it is. And for example, on the startup of the application, I can read also from a config and build up my DI container especially properly and say either I will send it to service bus or a make a Redis pops up. Whatever makes sense here in that situation. So this is, of course, a non-functional, just purely Gang of 4 pattern style object-oriented version. Yeah, and how we could do that? That could look like this, for example. So we just pass, we pass the call further to the call of the proper instantiation. But what is the difference to the version that we had before? The difference is that here we get immediately the result back. So we don't get the possibility to make this call later on when we want, when we need it, maybe multiple times. No, that's just the call itself. So here we're doing the call, and the decision is done on every call. On every call to this method, we go here and make this stuff. And depending on what it is, that could be maybe a somewhat expensive operation and maybe not the optimal path to do it. Okay, when we take a look at what pattern matching is one of the very important things to write terse code really means, and we have it in C# now for a few years, then we can just show some examples. So for example, pattern matching could be used to get some information about the state of an object. Let's consider this really being a system object. So it could be probably anything, but we say if it is a number, if it is an integer, then I want to return that integer, and I can immediately write a name for a variable here, and I know if I am inside, or the compiler also knows, and that's the nice thing, if we are inside this if, we know this is a typed int. So we don't have to cast here or something like this, because here we already have made sure that this is actually an integer. We can even combine it and make more complicated and say, okay, same idea, but now we call it even negative integer, because here we add another predicate to it, and we can make a more complex version of that same idea. Or we can do something like this, a little bit nicer maybe and easier to read than the usual stuff that you did here, say if I'm between 0 and 9 inclusively. Or I could even do more important, more complicated things. Just I could say, okay, there is employees, and if these are read-only lists of workers, then I could, because I know it's a read-only list, I know I can use an indexer. I can ask the first one, is the first one an electrician? And if it is an electrician, I can ask her to change the lamp. And that's pretty nice. Of course, you could have done it the other way around without pattern matching, but it would be way more code and it would not be so safe, because you would have to have a check and a cast And of course, those have to be aligned. So yes, we all did it back then. So feature-wise, what we see here is nothing new. We can do that. It's not a problem to be unsolvable in formal languages, formal versions of C# or other languages. Of course, every language can solve such problems, but with way more things to do. So I think the thing is it's way more expressive. And if you're going functional, it will be good help if things are more expressive and we don't have to go through so many hoops of checking things and casting things and changing types and something like this. Okay, so for example, if you take a look at this, also this you could have done in other styles, but this is a pretty dense usage of pattern matching. Of course, it's not even using a list pattern, for example, that could be even more complicated or involved. But here it's pretty nice. In just a few lines, you can say, okay, I get a person. Obviously, person can mean different things. If it's a worker, then I want to have its profession and use that. If it's just or if it's even an employee, I would say if it's an active employee, I want to use his department. If it's an employee but an inactive employee, already retired, for example, I want to have his last boss. I can use that. And if it's neither a worker nor an employee in some version, then I just want to say, okay, let's take the hobby, I want to use that. And here you would have to do a lot of casting and type checking if you would do it without pattern matching. So that's just an example how expressive you could go and even reach into some details and sub-objects of a greater structure that you might have. Yeah, so now let's talk about trains. Let's go on a journey. Here you have a very, very simple action of a controller, of a typical ASP.NET controller. How could it look like? It could look like this, that you say, okay, I get a name from my call, I look up the name via some customer service, I get back the customer and say, okay, 200, this is my customer. So that's nice and naive because things might not go well all the time. So you have to care about all the different things that could happen in reality. So for example, what if there is no customer with that name? What would you do there? And in that case, you could decide, okay, we have nullable reference types now, so we could say, okay, let's return a nullable reference type. And if I find the thing, if I find that customer, I return the actual object. If I cannot find it, then I return null and I can check for that. Sure, problem solved. So that could look like this. I make a normal check towards null, do my stuff and say, okay, no content if I haven't found it, and our okay customer if we have it. Fine. But what about this one? Wouldn't it be nice to be more explicit about the fact that it could be a customer or maybe not? Even more than just saying, it could be null and this billion-dollar mistake thing in our code. So here, the change that we have here is that the customer service find method does not return a nullable customer, but it explicitly says, maybe I have a customer. And as I have this here, of course you could use var here, but I just have it here for clarity. You can say explicitly, if this customer has no value, so it is not a customer, then I'll do my logging and no content. And otherwise, it has a value. I can access that value and use it. And that's now a real valid customer, not a nullable customer, hopefully. Of course, you could do a maybe of a nullable customer, but that would be somehow weird, yeah. Okay, next thing we should maybe care about is what if the database is down? Because the two situations that we described before were just real valid situations. I look up a name that exists, I look up a name that does not exist. But what if the database is not there? What if our service is down or something like this? Yeah, we still have to do something about it. Could look like this. So we could have a big try-catch block and say, let's make our thing that we did before. And in case something happens there, let's make a try-catch. And here we do and log it and say, okay, we have a problem. And this is the message we have. We could do that, of course. But if we take a look and say, the thing that we really are interested in is here. And everything else is just blah, 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 make it resilient, make it work, even if bad things happen, and return the proper status codes over HTTP. So it's really a lot to do, and the interesting part is just buried within all these many lines of additional code. So maybe let's try again. Let's reset our thing. We're working on stuff and trying to improve a little bit, but at the end still it's not so perfect. So let's think again about this. What about if we say, okay, we have a simple pure function that is there to divide two numbers. Okay, I can say I divide 1 by 2. We know that's possible. So we get an output. That's fine. And we all know we could also try this, and it won't work. And usually, if we don't care for anything else, there will probably an exception happen. No matter if you ask for this variable, if it's 0 or not, but in that way you don't have any other possibility than just throwing an exception. Otherwise, you could make a business decision that dividing by 2 returns 0 or something like this, but mathematically that's of course bullshit. Okay, so I would say let's go for more explicit codes to make it really clear what we want to do and what is going on. And yeah, in reality, it's really nice. So or some of us might have children, and so we are going down and being not too explicit just with the code. Okay, and the thing that we want to talk about now is railway-oriented programming. And the idea of railway-oriented programming is that with everything you do, you could end up on one of those two tracks. You could end up on a success track, or you could end up on a failure track, and then proceed with that. So what does it mean? How could that look like? Railway-oriented programming was coined by Scott Vlashin. Scott Vlashin has this tremendous nice site, F# for Fun and Profit, and here he has a lot of things for the stuff and other things regarding domain modeling and using functional paradigms. And although the language at the site is really very much about F#, it has also very valuable content for us C# developers, if I may say like this. So the basic idea, as said, is this. You do some processing of an input, and either you come out on the success track or on the failure track. That could mean, in our version that we divide 1 by 2, we come out on the success track. If we use the 0 here as the denominator, we come out on the failure track. How could it look like? Of course, we have to do something with this method that it really supports this idea of railway-oriented programming. And the thing we have to do, what can be seen on the signature, is that we do not return an integer or a double, whatever, but we return a result of that payload's data type. So we say, okay, this is a result of an integer, and we know that means that could be this integer, or this could be something on an erroneous state. How could it look like? This result can be really made very, very simple. There's no big magic behind it. Of course, in reality, it gets a little bit more complicated, and you might add a lot of convenience to it. But the basic idea could be something like this. So from the interface here, you just have a value. That's the of t, that's the type, the payload type that you want to have. Or you have a string, that's an error, because that's the message that says this is the problem that we saw. And then you might have, and also that's already convenience, you might have this information, is it in a success state or are you on the failure track? Yeah, so not too much to worry about here. Of course, there are libraries out there that already provide you this. They use some different wordings maybe and additional functionality on top, but the basic idea is still very simple. Usually you also have another version of this where you don't have a string on the error track, but another type. That could be a result of t and then another type for the error. So you could even provide structured error information in that case. Okay, so how could the usage then look like? Let's try to get into the thing. So here we use this new divide function that says I divide sum through all, and I get a result back. And now I have to ask, because it's a result, I have to check, am I on the success track or on the failure track? Okay, was it me? Okay. So in that naive version, I would say, okay, no problem. We saw the API, so we can say, if we are on the success track, then do whatever we want by accessing the value. If we are not on the success track, then we obviously have to be on the error track, and then we can access the error. And here we have the string that gives us the information. The problem, of course, is you better make sure that you call it like this and not the other way around. Because usually what happens, if you're not successful and you try to access the value, you will hopefully get an exception, because that's never what you want to do, and also the other way around. So this is somehow dangerous. And the question is really, what's the benefit if you do it like this? So you start thinking, what could we do to make it a little bit more safe, a little bit more convenient? And one thing that might come into your mind is, okay, let's take a callback. Let's say, if I'm on the success track, do this. If I am on the failure track, do this. So it could look like this, that I say on success, this function, on failure, this function. Way better, because here you can't make it wrong. Because here, of course, you do not get the result where you would have to write result.value or result.error, because here we know it's on the success track. So here you get already the unpacked payload, in that case the ratio between those two numbers. And in this on failure you get the error message, the string already. So you have it, you don't have to unpack, you cannot make it wrong. And that's way better and safer. Of course, you often might have this combination where you want to do something on success and something else on the failure track. And that's the reason the next thing to do, pretty sensible, is to make it somehow easily chainable in a kind of fluent way to do it. So we just return, because if we go back, we did not need the result here, so we could return that result again and then just call the on failure here. Also, that's a little step, a small step towards nicer, more terse code on that, in that line. Yes, or you could even say, okay, we often have on success, on failure, we do either that or that, so why not make one method? It's called match here in that case, but that's just some fictitious library. Yeah? So it could look differently in the library that you want to use. You could use a match or whatever and say I pass in two lambda expressions or two methods, where I say the first one is for the success track and the second one is for the failure track. Even less parentheses and semicolons. Okay, so what you see here, the basic idea is super simple. You can turn around, take your computer and have it done in 10 minutes. It's not complicated at all. But the API that you get is really important, because you usually rely on a lot of such convenience functions, I will say. If you don't have those convenience functions, you don't gain much. And that's the reason why using a library off the shelf might be to be considered. So the API is important. And that's the reason from now on I will talk about the one library that is widely used. It's by no means the only library out there for C#, and the one that we used extensively in one of our recent projects and also the past project, and this is called C# functional extensions. C# functional extensions provides, for example, such a maybe type and a result type and other convenience around it, and it makes it extremely powerful. The first time we did the talk was, I think, 1.5 years ago, and there we had back then the impressive number of 13 million downloads. And now, just 1.5 years later, we have 22 million downloads. So it's really used very heavily, and I can totally, I would totally support considering using that library. But of course, there are others around because it's so easy to come up with, and just without maybe knowing Scott Washington or stuff, just if you think about the problem here that I tried to describe, it kind of makes sense to come up with that conclusion and to invent something like this. So there are a lot of other libraries out there. Just make sure that you play around with and make your tests to see what works best for you. So let's go to that example and maybe work on that further. So we are back here in this get customer action method. And here we again have this result that we already saw before. And here we couldn't really use almost the same syntax as we already saw, but here in C# functional extensions, it's called is failure. And I think on the other slide it was is error. But it's the same idea. So we get our result, we ask if it's a failure, then we print out that error. Otherwise, we say, let's take the value that we obviously have because we're not failure and return a 200 OK. So we can work further on that and try to make it even more tense and even less code. So one thing that we could do is switch to this fluent syntax so that we say, OK, customer service find, that returns a result. So here we can say we found it, yes, or we did not find it. Or the database was down, maybe. And then we can say tap error. That means when we are on the error track, we do something with this information on the error track. In that case, typical case, we just log this error. But nothing else changes with this result. And then we use this match that we already saw and say on the success track, our 200 OK, and on the error track, we return a problem sum 4xx. We can go further. We can think about, okay, what about if we want to be very explicit about we haven't found it in the database, or we have found the customer in the database, or we could not access the database. So what we could do here, we could of course combine it and say, okay, let's make a result of a maybe of a customer. Yeah? So that could mean, it could be that we get some information from the database, or we have a problem, we have an error. And if we get something from the database, then we have that information maybe customer, because we could have found a customer in the database or we could not have found. So that's just a maybe, no more information added to that. And that's the reason why we have here a result of a maybe of a customer. We could do that. Let's think about it if it makes sense, but it's possible. So we take here this result and say, if we're on the failure, so we could not access the database probably, or some other basic problem, then we log it and say, okay, for 100 we have a problem. Otherwise, we have maybe a customer. This result, the value of this result is the maybe customer. So here we have a maybe customer. And here we know we have talked to the database successfully, and now let's see what came out of it. And in that case, we say, okay, if it has no value, we have no more information because it's just a maybe, not a result. We say, okay, let's log it. It's fine to not find the customer we were looking for. It's just a find method. So we just log information and say we have no content. And otherwise, this maybe customer has a value that we can access. That's the customer. Okay, still, if, it's maybe not the thing that we want to have, because we every time have to take care that we do not access things within a failure track that are not available on the failure track. So let's make some fluent version of that. We could also do the thing that we saw before. We can say, okay, the customer service find returns the result. In case of an error, we log that error. If we are here, then we say we have a result. And in case of a success, we do something. In case of an error, we do something else. In case of an error, we could not talk to the database. We return a problem to the caller on the HTTP side. On the success case, we know, okay, we have maybe a customer. Let's see. And here again, also the maybe has a match on it. So in case we have something, we say, okay, that's the customer, let's return on 200 okay. Or we don't have and in that case, it's just we don't have a customer, no other information. That's the reason why we don't have a parameter here. We returned a no content. And as you see, this is a screenshot, and Ryder already said, you could do better here. You could make it more short, because we have here, it's maybe not too much lines of code, but we already have 4 lambdas. We have 1, 2, 3, 4, 5. 5. So it's 5. It's, yeah, we are used to read lambdas now, but still maybe not the super most approachable thing to do. So we could try to adhere to these hints that we got from our IDE and say, okay, sure, let's make this one here shorter. So still we have 1, 2, 3 lambdas, but we could even do better, because the same thing that the pattern that we used before from that lambda or that lambda to just using the method group syntax, we also can do that here, even if the compiler doesn't yet know, because we just make a method that is just this, because this is a method with a lot of optional parameters, the one from the controller, but we can just provide one that has just this signature, and then we can do the same trick. So with a little bit playing around for 2 minutes, we could make it even like this. So we say, still the same story, just syntax went down to the as much as possible, I would say. So still, we're calling this service. In case of error, we're logging it. Otherwise, we are matching it. That's a single lambda that remains here. Of course, we could also get rid of this, but then that's going to be weird. And here we just match on the maybe and say either okay or no content. And otherwise, we say we have a problem. And this is just short for the longer syntax that we saw before, where we would have error, arrow, and problem of error. Yeah, so I would say if you want to go like this, go really that far, because then you have really the power of all the things to just put away as most syntactic thing that you can. Because I think the nice thing here is I have here the single call to the backend. Okay, I have here some information to observability, fine. And then from here on, we're just talking about HTTP, because we are here in an HTTP action method. And we are just mapping, so to say, the different situations that we see, either to an okay, to a no content, or to a problem. And that's pretty nice, I think. Yeah, let's go through some of the extension methods that C# functional extensions provide us. We saw some of those, but let's go through them and show typical use cases. So one is map. Map means if I'm on the error track, nothing happens, I stay on the error track, but the value that I have on the success track gets mapped to another value. And this has no possibility to fail. It just produces another value. I can do the same on the error track. It's called map error. We also saw multiple times our match. So no matter where we are, we just decide on some commonality on the output. And for both versions, I just can call different methods here. We can have a bind, that's very important. And the bind is there if you are already having a result. So either you are on the success or on the failure track. If you're on the failure, you remain there. But on the success track, you do an operation that on its own can turn out to be successful or not successful. So you could switch over to the error track if that operation fails. Otherwise, you stay on the success track. You could have something, for example, for validations. You have an ensure, and here you check just some Boolean or a predicate, because there are different overloads for all those methods. And you can say, if this is true, okay, let's stay on the success track. If it is not true, let's take this on the error track. On failure compensate, the other way around that we saw before. It could be that in some situations you say, okay, I know we have blown up, but we can do something about it for whatever reason, and you go back on the success track. Could make sense. Never used it often. We also saw the tap. The tap is just, as the name says, you're just tapping your finger into the flow, into the stream that is coming by, and see what's there, but you don't change it. And tap here and tap error on the error track. So typically used for side effects such as logging, typical example. Okay, let's take a look at some realistic example. Consider we have a home automation system, and this home automation system can control a variety of devices that you might have around your house. And for example, you could control the heating of your house. And one thing that you could do is that you could think of, okay, let's build a system looking like this. I create a schedule because I know the actual tariffs, I know what the weather is going to be, whatever. I check the validity of the schedule that I got here. I optimize the heating for other parameters that I might know about my appliance, for example. Then I want to log what happened up until here. And if everything was fine, I want to send the schedule to my devices, maybe update some metrics, and in error case, I want to log the errors. So nothing super fancy, but let's take a look how we could maybe plug those components together using railway-oriented programming. Okay, now let's go from box to box. This box says, so I tell you, this box could fail. So the attempt to create the schedule could fail on its own. The validity check, of course, says valid, not valid. So it's a yes, no. The optimization could fail, and also the sending to some IoT devices out there in your house, of course, could fail as well. So what does that mean? That means here we get a result back. Here we have to check, can I stay on the success track, or do I have to go on the error track because the schedule that I got successfully here is not valid for some reason. Then if I am still on success, I optimize for heating, so I still get another result, and another result here for the sending, because also that could fail. For the methods to be used to plug those together, that means the result is just a result, but then we can take an ensure to ensure it is valid for whatever rules. Then we have to use a bind, because here we have a result. This produces a result, so we have to use the bind. And here we can just tap on the success track, and another last bind for the sending, for the result that comes out of the sending. And afterwards, another tap for the update of the counters and the tap errors in case something bad had happened. So if we put our boxes to the whole chain, we could imagine it like this. So here, just the alignment is a little bit off here. But you see this result, and as it is a result, it could have already failed. You could immediately come out on the error track and just go to the end until you log that error. Or you do all your operations, and all of those could put you out on the error track. But maybe everything works, or not. You cannot send, you're still on the error track, or it works, and you just go out to the system and make your side effects. Good. How could the code look like? Could look like this. So if you're not used to it, of course it's a little bit woo. There's a lot going on. And if you take a look at the block diagram, yes, there's a lot going on. But considering what's really going on and how many possibilities we have wired of success and failure behind each other, I think the code is pretty nice. So just go it through together quickly. We create an initial schedule. We ensure that it is valid. We bind it to an optimized heating method that could fail on its own. Here's some logging in between. We send the schedule, and here again we update some metric, and in error case we log it again. Of course, reality would also look a little bit more involved and not so smooth, but still the whole process, the whole combination of blocks that we saw before is here within these 10 lines of code. And if you would remove all the logging stuff, it's really just the number of blocks plus minus 1 probably. Yeah. Okay, some insights from real world. Yeah, you could say, that looks nice on a slide, but in reality everything is complicated. And kind of you're right. Yeah. So my relation to the whole topic is a kind of a love-hate relationship. Sometimes, currently it's more love, but there were times when it was a little bit the other way. So for example, you might find yourself in those situations where you, for the best of your ability, try to combine those things and write it together. And then the compiler says, nah, good idea, but not in all the details. And the details that you have to consider can be a lot because, as I said, all those methods have a tremendous amount of overloads because they are caring for things where you, for example, in case of, no, we don't have that here, but in case of that ensure, for example, we have one that takes a Boolean and one that takes a predicate. And then there's one that takes an async predicate. And then there's one that takes a task of a result. And so you have a lot of combinations, and it makes it super powerful because it's next to no combination where you wouldn't have a proper overload. But if you don't get it, or if you just have made your way around, or you already had it, but you made something else suddenly async, it could be that your whole nice chain that you wrote, and it could be way longer than this 10 lines, is somehow squiggles all around. And of course, the compiler is nice and tells you then, I don't know what you wrote here, and I have this possibilities. What do you mean? And each of those signatures itself is super complicated. So it could be really hard. And for that reason, if you are in those situations, you find yourself introducing temporarily some variables just to say, okay, up until here, I understood it and it works. And I don't write even a var, but a really explicit type because I want to see it. Yes, it's a task of a result of, I done it. And then you continue and continue until you somehow manage to figure out what the problem was. So that can be the situation where the love is a little bit declining. But if you have it, it's usually pretty nice. Yeah, and of course one could say, yeah, sure, but it's a library and it has 20+ million downloads, so documentation will be awesome, of course. Yes, and there is documentation for some parts, but not for the parts that you're struggling with. So there's a lot of trial and error and fighting with the compiler and trying to get understanding of the messages that the compiler shows you. Yeah, a few topics around the practicalities of using it. So one thing, for example, is it's totally nice to have the possibility to return an error information from any inner part of the system. But if you're using structured logging, what we hopefully do, so for example here in that case, so there's no dollar here, that's structured logging, you want to have that information. And if you just pass the string, a final string, down the line until you have a logging statement at the very end, then you lose all the detailed information, so you cannot make a proper structured logging. Of course, you can do something about it. One thing is that you use a result of T of special error type, and you provide all the detailed information about the possible errors in separate fields, and use that at the very end to build up a proper error message. Or you say, okay, then I log just there where I already have this information already at hand, and log in the very inner parts of the system, because there I have the most detailed information. So these are the things to consider about. And just the thinking about those problems is also, I think, very, very good to really think about how do we want to make error logging in our system. Because oftentimes that's just done, if you see it doesn't work, put another error statement in. And thinking about it up front is usually a very good idea. Yeah, something where, yeah, I'm still not super sure is if you have a mixture of this new way, so to say, so the railway approach, and then enclose this in a classical error handler. It's not perfect. Yeah? You could say on the one side, I never ever want to have any exceptions anymore because we have a result. And if something bad happens, then I catch maybe the exception from the HTTP call at the very back, return a result instead on the error track, and use that information. So you would never, for example, in a controller see an exception anymore. But it's really hard to do, and you can never ever be sure that you really got every situation where an exception could happen. And there could be a lot of situations. So some kind of final exception handling, maybe not that naive, but in a HTTP filter, for example, still might be a good idea. So I would say this is kind of a smell, but it could still be a valid pattern in your code. One thing that you could also consider is to use this idea of the functional core imperative shell, that you say, okay, here I am in my perfect functional world where next to nothing can happen. And if I am somewhere on a failure track, so a business validation, for example, fails, then I have proper ways to log there. And all the bad things that could happen, so making database and HTTP calls and something like this happens on the outside in an imperative shell where I do my try catch and all the stuff to get rid of those information. Yeah, takeaways. We have learned a lot while we were doing this. A few things that we already talked about. So we way more think about what happens in a failure case because we have it so explicitly in front of us. It's not something anymore that we can ignore and just care about if the first failures happen in production. We really have it in front of us. We have to decide what to do if that is a failure. And I think that's a good thing. Code could be smaller, more terse. If you're used to that kind of coding, that story might read pretty nice. If you are used what a bind means and what the difference of a bind and a map is and an ensure and compensate and stuff, that means something. And if you get used to it, it might tell a pretty nice story. It sometimes can be challenging to the author. Think of the squiggles. Exception handling. So in case something bad happens, not a business problem or the business validation fails, but something bad happens on an infrastructure level, think about that. So similar idea of to think about the failure. And the best thing is if you don't use it just for this very method, embedded in a big giant ball of mud of object-oriented goodness, that might not be the best case. So my suggestion would be really to think of a complete flow, ideally from, for example, one kind of controller back to the database, and try to make it as resulty, railway as possible. Then you get the most benefit out of it. But of course, you can decide also just for some parts. But that's not the best way to do. Okay, some resources. F# for Fun and Profit. I already told you about that website by Scott Vlashin. And what I totally recommend, if you don't know it and if you don't have it already at home next to your bed, is this book by Scott Vlashin, Domain Modeling Made Functional. It's all about F#, but read it no matter if you know F# or not, because it's such a great insight into how proper domain modeling could look like. Yeah. Good. Yeah, some of the usual things that you could do to find us. And I would say your question, lieber Kaspepi, is probably waiting.
Go back to the previous slide.
Sure.
In your experience, how long does it take for a new developer to get used to this kind of thinking? Because I can see it's very terse and it's very nice, but I'm much faster reading the long code with the ifs and the returns. How long does it take to get used to it?
I would suggest, ideally you have at least one person that is really fond of this way of doing it, that can really help. Otherwise it can be hard. But you can do it the same way as I described it on the slides. You can just start kind of naively and use this if as failure and do stuff, then get your bloody nose and think about, maybe it could be done better, and then you learn along the way. I would say this is the best idea. So to get such a big chain, as I showed it before, done at the very first, from the get-go, it's probably not making you happy. Yeah, so really making small steps, see where it shines, see where the problems are, learn along the way, because there's a lot to learn. Yeah.
Maybe not a question, but if you want to teach someone this, let them do a Rust beginner's course and they will be glad to be able to go. Because I saw a lot of concepts that also are happening in Rust.
Right.
Then you're happy they're in garbage collection and everything.
Yes. Don't have to care about ownership and whatnot. Yeah.
Yeah, I'm actually more thinking about code reviews. When we have a team and one or two people start using this new way, the other won't be able to review the code because it would be really hard for them to understand. You would have to onboard the whole team.
Yes.
And then it would be interesting how long it takes for everybody to pick it up and to be able to read it in a code review. I don't know, Azure DevOps window without compiler and IntelliSense and see what other overloads are there.
Yeah, so it's definitely a good idea to make it a team decision to try at least for the next 2 sprints to go in that direction. Because just, hey, look what I did the last 2 weeks, this is my PR, might not be the best idea. Yeah? Okay, other comments so far? Good. Thank you.
All right, then I'm gonna take over again.
Here you go.
Sure. Thank you very much, Paul. Thank you for coming all the way to Linz. We got you a small little present.
Oh, thank you.
Please, one big round of applause for speaker again, Paul Rohorzka.